coin sum, and this problem statement states that you have n coins with positive integer values. What is the smallest sum you cannot create using a subset of the coins? The first line has an integer n, the number of coins, and the second line has n integers x1 to xn, which is the value of each coin. And our job is to print one integer, which is the smallest coin sum missing. So if we take a look at the example, we have 2, 9, 1, 2, 7. And the output is 6. Then we can clearly see that it is 6, because if we add 1, 2, 2, which is 5, then the next missing sum would be 6. Here we are. So the trick is that the smallest sum is always the current maximum sum plus 1. So as how I ran through it earlier, we have to sort the array so that we can cheaply increment and minimize the running sum. So for this example, we have 1, 2, 3. 1 plus 2 equals 3, plus 3 is then equal to 6, right? So then if we use the trick, the smallest sum is always the current maximum plus 1, then the output would be 7. But for here, we have a huge gap, right, between 2 and 10. So if we run through this, 1 plus 2 is 3. Then the next smallest sum would be 4 instead of 1 plus 2 plus 10, which is 13, and the answer should not be 14 if we only take that trick as the rule. So aside from that, our logic also needs to check for the gap. So here's the code. We have n is equal to this is just basically taking the inputs, and like I said, we sort it, and then we have a accumulator variable result equal to 1, and this makes sense because then we have let's say we go back to the previous thing with 3, 2, 1, right? So in order to output 7, we need the extra 1 at the end. Now, in order to account for the huge gap, we have to check that so for each coin in the array, if the current number is greater than the accumulator variable, then we break, and then we just print the result, right? So that's just saying, okay, 1 plus 2 is equal to 3, but then and then that's obviously accounting for that we looped to 2 already, and then the next number is 10. Now 10 is greater than the result variable, which shows that we have a huge gap, so we don't account for the 10. So we just break from the loop and then print the current result. So we have, so then for the example of 1 to 10, it'll print 4, right? And then this is just if that doesn't occur, then we're still within like a cheap minimized scenario. Then we just keep accumulating the coin value. So this problem was just a sorting problem, and you just had to realize that, okay, we want to sort so that our end sum, our output, is always going to be where we always guarantee to be the most minimized as possible.